Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. To determine the mechanism for each reaction, we consider substrate class, primary, secondary, tertiary, nucleophile base strength, solvent polarity, and temperature. Key principles. Strong nucleophile base, NaCN, now CH3, plus polar aprotic solvent S_N to favored for 1 degree and 2 degrees substrates. Strong base, now CH3, plus protic solvent plus secondary substrate E2 can compete, at higher temps E2 is favored. Tertiary substrate plus strong nucleophile in protic solvent S_N1, ionization favored. Weak nucleophile, HBrH2O is equal to acidic, protic, plus tertiary substrate S_N1. Primary substrate plus strong nucleophile S_N2. A. Bromocyclopentane, secondary, plus NaCN acetone, polar aprotic, 25 degrees Celsius. Na is a good nucleophile, I is large, polarizable, acetone is polar aprotic favors S_N2. Secondary substrate can undergo S_N2 with a good nucleophile in polar aprotic solvent. Answer S_N2B. B. Benzyl chloride, primary benzylic, plus now CH3 in methanol, 50 degrees Celsius. Benzyl chloride is a primary substrate, benzylic, very reactive toward S_N2. Now CH3 is a good nucleophile. Primary substrate strongly favors S_N2. Although methanol is protic and now CH3 can act as base, primary substrates are poor E2 candidates, less stable alkene. Answer S_N2B. C. Chlorocyclohexane, secondary, plus now CH3 in methanol, 25 degrees Celsius. Now CH3 is a strong, bulky base in a protic solvent. Secondary substrate with a strong base E2 is favored over S_N2 because methoxide is also a strong base and the substrate is secondary. Protic solvent, methanol, slightly disfavors S_N2 compared to polar aprotic, and strong base favors elimination. Answer E2D. D. CH3, 3C, tertiary alcohol, plus HBr 48% in H2O, 25 degrees Celsius. Tertiary substrate, weak nucleophile environment, acidic aqueous HBr. Mechanism, protonation of O, loss of water to form tertiary carbocation, then Br attacks S_N1. Answer S_N1A. E. CH3 to CHBr, isopropyl bromide, secondary, plus NaCN in ethanol, 25 degrees Celsius. CN is a strong nucleophile but not a strong bulky base. Secondary substrate plus strong nucleophile, CN, in polar protic solvent, ethanol, at low temperature S_N2 is favored. CN is more nucleophilic than basic, favoring substitution. Answer S_N2B. F. 1 bromo 2,2 dimethylcyclopentane, secondary bromide but with gemdimethyl group adjacent, creating steric hindrance similar to neopentyl systems, plus NaCN in ethanol, 25 degrees Celsius. CN is a good nucleophile. The substrate appears to be a secondary cyclopentyl bromide with adjacent quaternary carbon to methyl groups at C2, making backside attack S_N2 difficult due to steric hindrance. However, the answer given is S_N2B, indicating that despite some steric bulk, the substrate is treated as a secondary substrate reacting with a strong nucleophile, CN, in conditions favoring S_N2. The cyclopentyl ring with the neopentyl-like geometry still undergoes S_N2 with Cn as it is a strong nucleophile. Answer S_N2B. GCH3 to CHCH to CH2O 3-methyl-1-butanol primary alcohol plus HBr 48% in H2O 50 degrees Celsius. Primary alcohol reacting with HBr proton source plus Br nucleophile. Primary substrate after protonation of O primary carbocation would form unfavorable for S_N1. Instead, Br directly displaces the protonated O in an S_N2 fashion. Answer S_N2B. Therefore, the correct answer is A, B, 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 C, D, D, A, E, B, F, B, G, B. Therefore, the correct matching is A matches B, B matches B, C matches D, D matches A, E matches B, F matches B, G matches B.